Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, hello everybody, let's get started. Thanks for coming back to yet another session on Kinect. I am really amazed and pleased to see that you want to hear yet more about Kinect. Well, we're going to test the outer boundaries of what more we can say about Kinect, and it's going to rely not only on our great presenters, Carlos and Eric, flying down the stairs, but it's also, this is a session for you to speak further too. We want this session to be as interactive as possible, as interactive as you can make it. If you don't do much talking, then we're not going to do much talking either. So this is going to be a short session, which is going to be great, so we can all take an early lunch and get a little bit more time. But we thought that based on feedback from yourselves at previous events, that you want to get, you want to see technology, you want to see technical details about Microsoft technology. And we try and do this every year at Faculty Summit, try and make our talks technical. Sometimes we get asked to do tutorials, sometimes just research lectures. We try and make things as technical as possible all the time. We do have to give some framing, some overview talks like my own and Anoop's yesterday. But you've just seen in the previous tutorial an overview, a sort of quick guided tour by Gavin, the general manager of the engineering team in Microsoft Research, giving you a quick taste of what developing with the SDK looks like. To offer you a deep dive, we have two of the actual developers of the SDK. And it's a real privilege, I think, both for me to work with these guys, and also for you. You don't often get to speak to the real developers in Microsoft. We kind of hide them in our dungeons, and you just don't get access to the real developers. Now and then we let them out at certain conferences, but generally not the sort of conferences that you folks attend. Generally not research conferences. So this is a rare moment for professors, faculty from around the world to talk to some of the actual developers at Microsoft, see that we're real people too, and get into some of the more nitty-gritty questions that some of your students might have, that you might have, and anything further that you're still not sure about the Kinect SDK. The developers do have some thoughts and preparation for this session to say, but really we're looking for you to help shape this dialogue. So please don't hold back on questions. Clearly there are many things we can't answer. There are limitations on the device, on the technology. Some are business limitations. Generally Microsoft doesn't talk about technologies that we know that are coming, you know they're coming. Craig Mundy's talked about that we're working on. Generally, you can assume that what Craig's talked about on Monday, in some shape or form, should be available in the coming months and years from Microsoft. But it's hard to make commitments if those commitments are not already made in Microsoft. So let me move on quickly to my colleagues. It's been a great team on the Kinect SDK using many people from around the company, but these guys are the core of what's behind the Kinect SDK. Carlos has been focused on audio, and he'll speak first, and then Eric has been focused more on the vision and skeletal tracking, and he'll speak second, or we can get together and we'll speak together eventually. But do think about your questions and drive the dialogue from yourselves, please. Thank you.
Thanks, Stewart. So like Stewart said, I'm Carlos Garcia. I'll be talking about audio for the Kinect. And I do have a little architecture slide, just give an overview of how the audio works for Kinect. Beyond that, I'm sure there's a mix of people of what people's interests are in. People may have tried the SDK, people may have not, may have run into problems. So like Stewart said, I'm really looking to you for questions and to try to answer any questions you may have. I have some questions on my own that I know other people have come up with, so I can go over those as well. So to begin with, I want to show what the audio stack looks for Kinect. Some of you may know the Kinect is a 4-element microphone array. So the first thing we have in the stack is the driver. And the driver gives us the raw audio from the 4 microphones as 4 channels of 16 kilohertz 32-bit audio. The nice thing about the driver being is that it is a USB class audio driver. This means it's a standard audio device on Windows. So if you plug in your Kinect and you install the driver, you could use it as a regular Windows microphone. And the nice side effect of that is that you get access to the audio via native Windows API. So all the Windows audio APIs that you normally would use for a regular microphone, you can use those to get the audio from the Kinect. But of course, just having the raw audio doesn't give you all the advantages that Kinect can provide for building audio or speech applications. So on top of that, we provide a COM object, a DMO, a digital media object, that can take that 4-channel input and apply several DSP algorithms, such as echo cancellation, noise suppression, beamformation, and then give you, as an output, a single channel of clean audio. And that's probably what you want to consume if let's say, you're doing speech. But being in academia, I'm sure many of you may want to just get the raw streams and do your own beamformation or your own algorithms on top of the raw data. So we provide both interfaces for you to hook into. Now, beyond that, that is a native COM object, so you interact with it with C++ as a regular DShow DMO. Beyond that, we have a .NET library, a C# wrapper for all the managed developers, which we have quite a few of those. And that provides a slightly friendlier interface, just as in general, .NET is a little bit easier to use. So you can use that if you like, and I can go into some examples on how you do that. And finally, this C# wrapper is the sort of the glue that allows you to connect into the speech platform. The speech platform right now, the preferred mechanism is to use the managed interfaces, and using this C# wrapper, you can hook into the speech API. And I put this in a different color because it's important to know that we don't, as part of the SDK, we're not giving you a speech API or we're not giving you a speech runtime, but the standard, I guess the standard speech platform from Microsoft hooks into the Kinect, and that's what you use. So any kind of speech-enabled development that you've done previously just carries over by plugging in the Kinect this way. And here at the bottom, I show where your application may hook into, and as you can see, there's different levels or different places that you can get data from. The native 4-channel audio, sort of the clean processed audio through .NET or native, and then finally you can hook it into speech. So just sort of to guide a little bit the rest of the talk, can I get a show of hands of how many people have tried the SDK, have played with? Okay, very few people. Okay, so I have prepared roughly a list of common problems that people run into. I think it's still valuable to go over those for everybody that may start using the SDK. This is what we found are the common gotchas that people get into when they try to use Kinect. So I'll go over those first, and feel free to just interrupt at any time with questions, because I prepared this, but I'd rather answer your questions that you have than my own that I thought could be interesting. So please fire ahead if you have any questions. Just raise your hand. So one of the most common ones, and I guess I won't start from the top, just to start with the basics, is can I write a 64-bit application? And this gets a lot of people because it may be a little misleading. We do have a 64-bit and a 32-bit version of the installs, and that is mainly because of the driver. The driver has to run natively as in the business of the OS. But the runtime, the libraries that we provide, for this release, we only have 32-bit binaries. This means that you have to write 32-bit applications even on x64, and Windows can run them fine. That's not a problem. And in fact, if you're running native, it's very obvious when you're trying to link that it's not a 64-bit app. When you run into managed, one thing that is easy to get wrong, I guess, is when you look at where are my properties? This guy. When you're building, by default, any managed project will default as a platform target to any CPU. And the way this gets you is, if you're on a 64-bit system, Visual Studio will compile to IL, to bytecode. Then the jitter, when it loads, is going to see, oh, I'm on a 64-bit system. I'm going to JIT to 64 bits. So therefore, you end up in a 64-bit process. The next call tries to load the native DLLs that are 32-bit, and you get this nasty exception that says the image is not of the right format. It's kind of cryptic. So this is just something that a lot of people run into. And what you do is, from here, you set it to build precisely to just x86, so that regardless of the platform that you're in, this .NET code is going to get JITted to native x86 code. You're going to be in a 32-bit process, and then all of our native runtimes are going to load without a problem. So things to keep in mind, all of our samples ship with this setting as this. So the most common thing that happens is people get our samples, they run it, it works, they get the exact same code and put it in their project, right? But they didn't copy the project settings. So it's very easy to not see that part. And that's why we get this question a lot. So something to keep in mind the first time you try to bring out some of the sample code and run your own projects for the first time. Yes?
Is there a mic? The mic rows will come later, so I'll ask a quick question. Maybe I can use the mic.
Sure.
Could you turn this on, Daniel? OK, thank you. So we're going to start asking questions. I'll start with one. So on that setting, which is just to say a little gotcha that we've seen a number of times. It's the kind of dumb question, but I'm like a dumb programmer. So is that something that is always going to be there as we refine the SDK? It's just kind of a little annoyance, or is there any prospective evolution of that, which is going to this is just like a temporary gotcha? Is it something that's always going to be there to bother us, just as a little annoyance? Do you know?
Well, I mean, it is a limitation of the current implementation of the SDK, because we only built a 32-bit runtime as a first iteration. If later iterations, and I can't say exactly when or what we're going to build, but if later iterations we build native 64-bit versions of our runtime, then we won't have this problem. So yes, it is a limitation of the current version of the SDK.
Okay, thank you.
Do we have any other questions around this or anything audio related? No, OK. So and I should say this is probably the only bit of that I'm going to say that applies also to the rest of the APIs, video and skeletal. So this applies across the board. We're x86, and so you have to be careful when you run managed code. Now, since I see most people have not used the SDK, I think it'll be more valuable for me to go into the basics of how you get audio from the Kinect, rather than going to some of the finer details, if that's the majority of your interest. So this is one of the samples that ships on the SDK. It's basically a very simple application that records audio and writes it to a WAV file. And you'll see it's very short, which speaks to it's very easy to use, or at least that's my opinion. So first thing that you in general want to do is just have your thread on a high priority, because you're capturing audio. So you need to be sampling on a regular basis. And if you get preempted by some other process or some other thread, then you're going to start dropping samples, and you're going to get choppy audio, which is important not only if you're recording, but if you're doing speech. That just totally kills speech to have samples get lost. But here we get into the sort of the meat of the Kinect API, and the main object you use is a Kinect audio source. Yeah, you create one of these objects, and by default, this will hook into the first Kinect that you have connected. Most people will have one Kinect. I'll talk a little bit later on how you could do, if you have multiple Kinects, how you can address them. But since the most common scenario is for people to have one, then this is all you need to do to start. Now, the system mode is where it gets interesting, and where some of the many capabilities that we provide in this SDK start to show. Because if you go system mode, this is called OptiBeam Array only, but I want to show you the options that we have. OptiBeam basically means beamforming for the four-element microarray. Basically create a sort of a virtual beam of listening direction using the four microphones. We could do it just that, or we can have acoustic echo cancellation going on at the same time. So if you're doing like a Skype, I guess Skype is a good example now. If you do a Skype type of application, then you want to cancel the voice that is getting spoken on the far end. That's exactly what acoustic echo cancellation helps you with. Or if you're doing a game and the game is playing music, you don't want that to be getting fed back into your microphone. So that's what echo cancellation helps you. And then if you don't want to do the OptiBeam, for some reason you're not interested in the microphone array for beamforming, you can just do a single channel and either do echo cancellation or just do noise suppression and gain control. And these are sort of starting points for the mode. Because, for example, I'm going to start with this one. But if you go source dot, you'll notice there's several properties you can turn on and off. There's acoustic echo suppression, gain control, parameters like the echo length, frame size, the beam angle. There's different modes of doing microphone array processing, noise field, noise suppression, and then we'll get into sound source position later. But there's all these things that you can turn on and off, depending on the application that you have. And one very good example is for speech. In general, I guess a common application, if you're just recording, you want to get the best quality, well, you want to sort of do all the bells and whistles. But for speech in particular, you don't want to use gain control because that confuses the speech recognizer. So an accuracy could actually go down. So it's I guess just to highlight that it's important to have this level of control over the APIs. So let's say you set your options. And again, I'm going to just glance over the beam stuff for now. And then this just creates a file, writes the WAP header, so not terribly exciting. But here's where you go and then actually start capturing. So you call start. And when that returns, and I guess this code doesn't show it because of the bar here. By the way, how many people are familiar with C# in general? Okay, so maybe 30, 40%. Would the rest of people be using this from C++? So, yeah, okay. Okay, so that gives you an idea. I'll stick with this C# application for now, just because it's easier to show the condensed version. It's a lot less verbose than the C++ code. But for those of you that are familiar with .NET, this Kinect audio source returns a stream, which is the basic base class for stream data in .NET. So just like a file stream inherits from stream, network stream. So we just decided to return the same type of stream so that it's a familiar API. And because the speech engine, that's what it takes. It takes a stream to consume audio from a source. So that's another reason why that's what you get. Apart from that, you basically just start reading into a buffer. And then the WAV file is just a very simple format, so we just write it out. And I guess those are the basics of how you get audio out of the Kinect. As I mentioned, we have the beamforming and the sound source localization. These are the APIs that can give you information on where the speaker or the sound source is. It's again based on the phase differences and the slight differences on the signals that get into the four microphones. It does some estimate or a good guess on where the sound position is. And then it can create this, as I said, this virtual beam to try to have a directional microphone, a virtual directional microphone. But you can query those values at runtime for your own application. So I feel like I've done a lot of talking. I want to get some questions.
Could you just specify the resolution of the beam? What kind of detail is the angle of the beam?
So that's a very common question on the forums. Like, what's the difference between? You'll notice these two APIs. There's a beam changed event, and then there's a sound source position. Here's the confidence, and here, over here, you see we show the position and the beam. The position is, as I said, just the guess of the localizer where you're at, and it's about 2+ degrees standard deviation confidence. Now, based on that, the beamformer may choose one of a set of predefined beams, and these are 10-degree increments. So depending where the sound source is, with some hysteresis, it's going to decide to change the beam that is listening on. So I don't know if that makes it clear on what the difference between the localizer. Yes?
Can you explain tell us a bit more about the confidence measure? What is it getting at?
I can tell you it's basically a 0 to 1 number, giving, that is trying to give you an idea of how confident the sounds this localizer is on the measurement that it's taking. It basically has a queue of measurements, each one based on different factors, right? Intensity and things like that. How likely it is that that is the actual sound source. The specifics of the algorithm I'm not very familiar with on how it does the SSL.
What's the update rate on the position?
The update rate, it basically updates on every frame, and a frame is by default 256 samples, and the sample is 16 kilohertz is 1 over 16,000, so you roughly get the idea. Yeah, so basically all the pipeline updates on a frame-by-frame basis.
Yeah, is this thing on? Yeah. Okay. I asked this earlier, but I'll ask you because you seem to.
4?
4?
Okay.
4? Hello?
I think it's on.
Really? Okay. So my question is, can you tell it where to listen? Can you give it a position or an angle?
Yes. Yes.
How do you do that?
So I'll just repeat the question just in case. The question is, and that's again a very common one, can you, instead of letting it guess the position of the speaker, can you tell it, listen in this direction? Answer is yes, and I'll show you the API is, I'll just use IntelliSense here. The first thing you need to do is set the microarray mode. This is an enumeration to external, right? So instead of doing like one of these algorithms for doing a beam, you're telling I'm going to give you the beam. So it's an external. And at that point, you can set, I think it's microarray beam angle. And this is double in radians, basically, that you give a position to. And we had this question before. This is on one axis, right? Because the microphone array is just linear. So we only have one angle on this direction.
So I had another question. As a naive audio guy, so the mics are supercardioid, I think. Is this beam angle? Does the beams look in a 360 degree periphery, or is it restricted or focused in a more front-facing?
It's definitely a front-facing.
It's front-facing.
Okay. And if you look into the documentation for this, will give you a link to the page that defines. It'll give you exactly the angles at which each beam is at, and I believe it's like from minus 50 something to 50 something. So it's a front-facing beam. Yeah. Any other questions? Yes. 3, I guess.
Can you easily specify a player index for the beam angle and have it hook up to the tracking code, or do you need to do that manually?
You would have to do that manually, unfortunately, at this point. Yeah. Any other questions? No? Yes. Can we get a microphone?
Can you hear number 4 out there? It's very quiet. It almost sounds
Is there any frequency selectivity, like the voice ranges you have, and for example, the cries of a baby, and because we are doing some projects on baby cry analysis, right? So is there any kind of restriction in the system?
I know there is just thinking back to the code, there is some places where it's applying some criteria based on the frequency bins. I mean, it operates this, it does on the frequency domain, and definitely filters out some frequencies that are not speech likely. So it does try to find speakers. So in theory, if you, instead of I'm speaking, and then over here there's, I don't know, some high-pitched sound, the confidence should be higher when it's pointing to me. Yeah. One more.
Are there any things we should avoid doing? I'm thinking, for example, I don't know whether or not manually changing the beam angle, whether that puts some transients into the signal processing code that might screw things up a little bit, and so we should avoid, changing the beam angle on every clock tick versus.
Good question. I actually don't know. I don't know at that level of detail whether that would.
But in any case, you're not aware of gotchas like that where we should avoid. There are operations that are in the API that are potentially expensive or destructive, and we should try and minimize using.
I'm trying to think if there's anything. Well, certainly most of the parameters, and I think the angle, maybe one of them, most of the parameters take effect. You have to set them before you start the capture. So you can't, like on the fly, turn off noise suppression, or on the fly go, echo cancellation.
Right.
So the vast majority of them are that way. The beam is one that you can actually change, because otherwise it would be useless. Yeah. And I mean, as far as expenses, it does have to do like a thread transition. So it has to marshal to another thread. So there's some expense there. Yeah.
Okay, thank you.
4 here.
Sorry, Carlos, I got another question. So these are all the questions I've been stacking up over the past few months. Do you know much about the speech SDK, knowing that it's not part of the Kinect SDK, but I wondered whether you could speak to the, if you excuse the pun, the speech SDK. For those that don't know about the speech SDK, can you talk about how many different languages it may cover, what this business about the grammar is, why I need like a Kinect specific grammar, and
yeah.
Can you speak to a little bit about the for those that have not used the speech SDK, the sort of breadth of application that might have, the depth of capability that it might have?
Yeah, for sure.
Thank you.
Yeah, and I have to say, myself, I wasn't very well versed in speech recently. I can't really claim that to be a speech guy, but I was amazed how simple it is to do speech with a speech platform on Microsoft. So I'm going to jump over to the speech sample, and here, this is one of my other bullet points. When you're working with speech, again, because we're an x86 runtime, or we are 32-bit runtime, when you run a speech app, it's going to look for the 32-bit version of the speech platform. So a very common mistake is you go to the website to download the speech platform to use with Kinect, and you get the 64-bit version because you have a 64-bit OS. And then what you get is an exception that says, oh, the platform is not found. And that's precisely because it's looking for the 32-bit version when you're in a 32-bit process. So again, little things to keep in mind. And here it explains it in the top of the file, but we all know we don't read those things. And here, I'll answer the first part of your question, Stuart. Here you'll see we're looking for this, what is called a recognizer ID. These are referred to, strangely, in the APIs as recognizer IDs, in the websites and in the documentation as language packs. And more technically, these are the acoustic models, so for the speech engine. This is the acoustic model that was trained for Kinect, for the audio that comes out of the Kinect. So it has been tuned and trained for that. It's English only. There are language packs in all sorts of different languages for the speech platform, but the only one that has been tuned for Kinect at this point is English. And again, it's one of the things where we can say, this is what we've done up to now. So it's another thing that you have to install. This in the prerequisite at the top. But then after that, you go back to creating your same Kinect audio source, like you did for recording audio, setting certain parameters. I mentioned gain control needs to be turned off. You get your recognizer out of these installed ones. And here, now you can in code, write a very simple grammar. You say, okay, I want to have a set of choices, and then create a grammar out of that, load the grammar into the engine, and then hook up to the events of speech being recognized or rejected. I start the stream, and as I said, this gives me back a stream. I guess this example is a little more explicit. And I set that as the input for the speech recognition engine. I tell it what format the stream is in, and then I just start recognizing. And at that point, the Kinect will start listening, and the speech recognition will basically give me events, and I'll show you the event handlers. This just prints them to the console. Rejected, hypothesized, recognized. So it'll just print red, green, blue as I'm saying these words. So as I said, the API is actually very simple to use. The complexity usually with speech comes with building the grammar. And for bigger grammars, you normally wouldn't do it in code. There's an XML format for specifying the grammars for you to build your speech-enabled applications. So
What's the difference between hypothesize and recognize?
Hypothesize is throughout, when it's getting the audio samples, I guess it's building a hypothesis of this could be this word. And then you'll get those events as those hypotheses are generated with certain confidence levels. When there's a confidence threshold that says, okay, this is good enough, you'll get a speech recognized event. And again, I'm not very well versed in speech, but that's what I observed. Anything else related to speech? Another important thing. This is using the Microsoft.speech set of APIs as opposed to the system.speech. The core difference is system.speech is the desktop version that comes with Windows. Microsoft.speech is the server version. The reason we're using the server version is the language pack, the acoustic model that we have for Kinect, the speech team has that for the speech, for the server version, which is actually a little bit more, it's a little bit newer algorithms than the one that ships with Windows. So make sure you get the server version of the platform. And the links are here in the samples as well. Let's see. Any other questions? No. I want to mention one more thing regarding .NET before, because this gets a lot of people. And it's when you're doing a WPF application, as you saw you probably can't tell just from the code, but both of these samples, the speech sample and the recording sample, are console-based applications. Just to keep it simple, the first thing that a lot of people do is bring this code into WPF or WinForms and some graphical, to give it some UI. And again, the first thing you'll see is you'll get an invalid cast exception on a background thread that is very disconcerting, and it looks very mysterious. And the reason for that is, I don't know how many people are familiar with COM threading apartments, but basically COM has this notion of objects that can be accessed on a single thread or on multiple threads, and it puts them in these things called apartments. And it turns out because our COM object runs on this background thread, you need to create it on a thread that is marked as MTA, multiple thread apartment. Otherwise, it gets created on a single thread apartment, which is the default on WPF, WinForms, and then you get these very weird behaviors. Let me show you what that looks like. So here's my code. Here's where I start my digital media object. Now, if I just call this from the UI thread on a WPF or a WinForms app is going to be STA, single thread, and that's going to get me into trouble. So what you do is, where is this? Oh, sorry, here it is. Is you create your own thread, you set the apartment state to be MTA, and you have the thread do the calls to create your Kinect audio source and do all your audio processing, and then you start a thread. So just little things to remember is make sure you are on an MTA thread whenever you're doing audio with the Kinect. And this is very common with, are very relevant for graphical applications. Questions, or should we move on to the skeletal fancy stuff? Yes.
That would be multiple connects.
Oh, thank you. Thank you. Yes. So, as I said, if you just have one, it just works. Here I wrote a very simple bit of code that just starts 2 threads, one for each Kinect. So what you do is, there's an API on the Kinect audio source called Find Capture Devices. This gives you an enumeration of devices, and then you can just enumerate one or the index that you want, and it gives you back a device info object. That device info has the device ID, which is sort of a GUI type of identifier, the name, the friendly name that you would normally see on or display to the user, and then the index. And the device index, that's what you need to set in this microphone index property, which by default is 0. If you don't do anything, it'll just grab the first one. But this is how you grab a specific device. So in this case, it starts, as I said, 2 threads doing 2. My second version, I was just lazy, I just copied the code. You could do it much more condensed, just say this device index of the second device, I guess. So that's how you get listen to 2 Kinects, or one if you just want to select one in particular.
How many do you have?
Good question. Eric, do you know how many Kinects can you have?
Don't know. For video, I think we limited to.
Depends on your budget.
On your budget. Again, these are only 150. I know we had some issues, and maybe Eric will talk more about that, but that you sometimes have to have them on different USB buses. If you put them on the same USB bus, there are some power limitations, I think. But as I said, I think Eric knows more about that than me. Personally, I've only tried it with 2. That's 3 works? Great, thank you. So we're up to 3. Any more? Do we have 4? Sorry. Microphone.
See, you are saying that one Kinect audio source you can use at a time. By the way that the way the program is written, can we do something like that? 2 different sources simultaneously being captured.
Yes. So I didn't show the top of the code, but this starts 2 separate threads. So these are going to run concurrently, and they're going to capture concurrently. And the way I was testing this, just the top thread, every time it reads a frame, it'll write a dot, and this one will write a dash. So if you run this, you'll see like dot, 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 dash, 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 dot, dot. So they're capturing concurrently. Yeah, that is possible. So I want to jump over to Eric, and I'll stick around in case there are more audio questions at the end. And so, yeah, thanks.
I don't have a slide deck. So my name is Eric Rudolph, and I worked on the runtime and the unmanaged layer, and with another coworker of mine, worked a little bit on the managed code for the video interfaces. And since I thought that most of you are going to be somewhat familiar with the Kinect SDK, I formulated most of what I was going to talk about today on sort of deep dive questions, and wasn't prepared for sort of a broad overview. So one of the things, so I prepared a sort of the most common questions that we get on the forums, the really hard questions, and I'm not exactly sure what you guys know or want to know. All right, so let me just talk for a minute about the Kinect SDK. When we ported it from the Xbox, we weren't sure what form the SDK should take, and we didn't want to look at the open source stuff, so we decided just to duplicate the Xbox SDK. And then once we were halfway through the Xbox, or through the API set, we were told that not only did the initial release have to mimic the Xbox SDK, but it had to mimic it exactly. So we didn't want to add any additional methods or features to the first revision, so that's the way it is right now. I can't talk for what's going to happen with the commercial release, but if you're wondering why the initial release seems somewhat limited, it was because we're confined to the Xbox API. So that limits some of the things we can do, like returning error codes or allowing record to a file or playback from a file, which is it's something that a lot of people ask about. So what you get right now with the Kinect SDK that we've just released is the ability to capture video in a couple different formats, a variety of formats, and capture depth and to get skeleton data. And with the current SDK, you can only get skeleton data from one of the Kinects. So how many people here are planning on using the Kinect for one of their projects? Is it everybody, or are you just here for informational purposes? Can I just get a shout out of some of the things that you'd be using a Kinect for so I can think about things to talk about? Like, I know that there are people using it for doing like maybe making 3D models and for robotics, and some people are interested in using it as a web camera.
I have a question over here. Is there any limitations, or have there been any experimentations in running it in an embedded system type environment? So, compact framework type scenario.
I don't think it would be a problem running it in an embedded system as long as it has a 32-bit processor and has enough speed. But it is processor intensive and does not run on a GPU, so it would require a pretty fancy embedded system so far.
Do you have any specs or specific requirements on that, or is it sort of try and see what fails?
Right now it's try and see what fits. There's a lot of optimization that can be done, but only up to a certain point. We don't use a lot of memory. And the database that we use, the skeletal database, is about 25 megs. And then there's the memory overhead for buffering on top of that and the runtime. But memory is not so much of an issue. It's more the CPU speed. And we do take advantage of multi-threading, so the more processes you have, the more efficiently it will run.
So just a quick follow-up on that. Would it be possible in your mind to disconnect or disassociate the device or the capture device from the processing? Meaning, say I had an embedded system that had the Kinect attached to it. Could it stream the data to, say, over a TCP port to something else that would then do the decoding?
Well, we wanted people to be able to do their own skeleton tracking, et cetera. So if I were me and I was having an embedded device and I wanted to do the processing somewhere else, I would just get the depth data or the video data out of it with the embedded system and find some way of compressing it, sending it over the wire. The unfortunate part is, with the current release, there's no way to point the source of where you get the data from to some other place. And we all know that people want that. And as soon as we give the ability to hook the input source and point it to somewhere else, yes, that will be possible. And they're aware that that's a concern. I would hope that we provide that shortly, especially for researchers that want to do repeatability studies for skeletal tracking and find out when something that they're working on doesn't work, and being able to repeat it on a frame-by-frame basis from a source on disk or a source that's provided from somewhere else. So back to my original question, is there people have ideas of what they're going to use the Kinect for? Is it mostly for, I mean, are you guys interested in doing your own skeletal processing? Is it mostly for being able to get to the depth camera? So I can talk a little bit about the depth camera. One of the things that comes up all the time is that because I goofed up, if you ask for just depth data, unlike the Xbox, which we were supposed to have parity with, when you ask for just depth data with this release, the depth data is in the bottom 12 bits. And when you ask for depth plus player index, when you turn the skeletal tracking on, all that data gets moved up by 3 bits. And that depth data comes in at 12 bits. And one of the things that we noticed on the forum is that the depth data, we get a lot of questions about why are there shadow zones, and that's because of the parallax between the IR laser and the depth camera, because there are shadow zones. And people keep wondering, how close can you get? Why are there shadow zones? Why, when I hold up my hand or something like that, do I see 2 hands when you're viewing the depth data versus 1? And that's because when the sensor is shining at your hand, you can't, the sensor, the depth sensor can't see the other side of your hand. So all that data that the Kinect sensor, the IR sensor, or the depth sensor can't decipher, it fills in with zeros. And anything that is closer than 800 millimeters or so gets set to 0. And anything that is farther than 4,000 gets set to 0. So we on purpose have set that value to 0 to say, I don't know, instead of saying we know that it's either too close or too far, because the Xbox team didn't want people to rely on a particular behavior. Some of the sensors can see data closer, some of them can see farther, and instead of saying which is which or allowing people to get to that data that's too close, we wanted a very known uniform sensor set. So we clamp that data between 800 and 4,000 so that we know that you will get good data from that. So, so a lot of people are trying to get as close as possible to that 800 mark so that they can do finger or hand gestures and recognition and such, and they see this shadow thing and they don't know what to do with it. As long as your hand is further away than 800, you can see these zeros in the shadow zone and either ignore them or try to recognize that they're not actually part of a valid image, that you need to treat them as unknowns. That's a very common question. When you hold up your hand and you see 10 fingers instead of 5, you think, what's going on here? Especially with the way the skeletal viewer is written, is that everything that's closer gets drawn as white. So as you move it in closer and closer towards the 800, the 0 shows up as white, and the 800 shows up as nearly white, so it looks like it's recognizing the same hand twice. So the forums actually are a very good place to look. I was surprised. I've been on vacation for a week, and I was surprised by going up to the forum and looking at the questions that have been asked. It's a very, very good place, unlike some other forums I've seen, for getting your questions answered. So I could answer a whole bunch of questions today that are specific to things that you guys have in mind, but I was really kind of shocked that the forums were such a good place to find out where other people had found out the answers to some pretty hard problems. So I'll just run through a list of some of the bigger issues, or the more frequent issues that have been asked that were kind of more technical. First question that comes up a lot is, can you use the Kinect as a webcam? And since it's not a kernel streaming device, and as far as I know, we have no plans on making it one, you can't use it as a plug-and-play webcam. And the second question that comes up a lot is, why does my webcam stop working when I plug a webcam into the same USB controller as the Kinect? And the answer is because it takes up too much of the USB bandwidth. So the camera never gets any processing cycles across the USB. So if you want to use a webcam and a Kinect, you have to plug them into different USB host controllers.
So it does work if you put it in different controllers?
Yeah.
Great.
Another question I get a lot is, it's all about the latency. People are very concerned that they get as minimum latency as possible when they start capturing frames, and that's both with just raw depth data or depth plus skeletal, and with video. And of course with video capture, one of the things that always plagues people is what happens when you don't have the CPU cycles to keep up at full speed. So to answer the latency question first is that we designed the Xbox guys designed the API to have the minimum amount of latency as possible and still never starve the capture thread. So on the PC, we duplicated that, and we have only a 1 frame latency. So, so what happens is the capture thread is always filling one of the buffers, and there is actually a memory copy that goes on, or a translation, because it decompresses the depth data that arrives on the USB wire and decompresses it into a buffer, and you could call that a memory copy. But as soon as it's done filling, it hands it off to the NUI runtime, which notifies the user that the frame is ready. There are no additional memory copies or buffering that happens with that captured buffer. It's handed off to the user as soon as possible, and then goes and tries to fill another one. So if you want the lowest latency on depth, then just request depth only and don't turn on skeletal tracking and don't turn on player index, and you'll get a very, very fast depth capture. If you ask for skeletal or player plus index, when it captures a depth frame, it has to first pass it through the skeletal tracker, which will definitely slow it down. But if you have a fast enough GPU, it's still only going to be a 1 frame latency. But that 1 frame latency will arrive later, after much towards the end of that 1 frame latency rather than the beginning, because it has to process the skeletal tracking. A lot of people ask me, how many threads do we use? We currently use 1 thread per stream type. In the future, we may use more threads to process skeletal data. But the depth and the video are definitely processed on different threads. That means that if you're using unmanaged, yeah, it's a single thread model from the NUI perspective, but you will see the CPU using a couple of cores pretty extensively. And another question is, do we use the GPU to do any of the processing? And the answer to that is no. We have too much of a wide variety of graphics cards, so we're unsure about how to unify that and put the stuff through it. On the Xbox, it's only 1 video card, and we can control it, and that makes it easy. One of the questions I get asked all the time is, suppose I want to synchronize video and depth buffers and be able to know that a certain video frame matches a depth frame for doing blue screening, or to be able to just match them up. And since video doesn't do any processing after it gets converted, it just gets handed directly to NUI, there's less of a latency on the notification than there is with depth. So depth, well, if you're asking for skeletons, so the depth goes through the skeletal tracker and eventually pops out the end and notifies NUI. So the user will always be getting a video frame first. The answer to how do you synchronize these things is to look at the timestamps and to keep a queue of buffers, of video buffers, and when you get a depth frame, match it to the closest video frame. If it's further than half of a frame away, it's probably not the frame that you want. Another question I get asked a lot personally and on the forums is, if I can open a stream and set the number of buffers that get filled, why is there even a parameter to do that, and how does that work? So in a capture system, you always want to be capturing to 1 buffer and looking at 1 buffer so that you never starve the capture thread. But if you capture too many buffers and have them in a row, you add more latency. So the real answer is set the frame limit, set the pool of buffers that you're using to whatever is the most convenient for your particular system. If you know that your CPU core is fast enough so that you never have to drop frame, then setting a pool size of 2 buffers is good enough. You can have 1 that you're looking at, 1 being filled and 1 that's ready. In that case, you have usually most of the time just 1 frame of latency, and sometimes 2 if there's a hiccup. If you have a machine where you know that you're drop framing all the time, but you always want the frames, you can set that frame limit to be a little bit bigger, so that when you recover from a CPU hiccup or some sort of processing that takes a long time, you have more than just 1 buffer waiting for you to process the next one. Generally, on a fast machine, I only use 2. There's an implication, though, that if you get a frame and you did take a long time to process the data, there might be another frame that's ready. So it's a sort of undocumented hint or trick that you can call get next frame again with a wait timeout of 0 to see if there's another frame that's being ready. So I talked about the nulled out data being, stuff that's closer to 800 being zeroed out, and the shadow zones. And the depth data is being different. I just saw something today on the forums that people have noticed that there's some small vertical discontinuities in a depth frame, and people were wondering if they were doing something wrong or if we were doing something wrong. And the answer is that in the hardware, the autocorrection for the depth stuff does a slight gain modification in a banding type of way. So that's not your problem, and it's not the PC's problem. That's just the way the camera works. Another question that comes up a lot is...
Eric, just on that last point, is that the vertical banding thing that's come up?
If you look at a wall that is facing at an angle and it's got a slight gradient to it, you will see columnar banding as it goes across the surface, as the auto gain or something like that tries to... Yeah, it's quantized to a certain extent. One of the things I've hit a lot is people that really want to make my life difficult by unplugging the Kinect at runtime and pretending like they're tripping over a cord. And people will say, well, how do I deal with a runtime streaming error? Because we were confined to the Xbox API, we didn't have a way to pass back streaming errors. So the simple answer is that all of the public APIs start returning the streaming error code once the Kinect is unplugged. The answer to that is to call NUI shutdown and then NUI initialize again after you've gotten that streaming error. Unfortunately, this has implications for managed code, and to be honest, I don't quite understand how that works in managed code. I think that what you're going to get is an exception that you should handle, and then in managed code, call NUI shutdown and then NUI initialize again. But that's the answer from the unmanaged side. People have asked, why can't we process skeletons from 2 NUI devices at the same time? And the answer to that is simply because the code that we ported from the Xbox wasn't reentrant at the time we ported it, and we're aware of it. And we do know that people want to process 2 skeletons at the same time, and we know about it. The other questions for doing multiple stuff is there a way for 2 applications to just subscribe to the same runtime to get images and skeleton data? And the answer is no, only 1 application at a time can get it. We didn't want to introduce memory copies, and the other reason is that because of the API set, one of the applications could be holding on to the frames and not letting the NUI pipeline be filling them. And one application could cause another application to stall. And that would, of course, not be good if one of the applications is doing it in not a very friendly manner to the people that are using the Kinect on purpose. So the way that you could solve this is write your own frame server, subscribe to the image and skeleton events, and then take that data and send it over the wire or via an internal system pipe to multiple applications that are waiting for it. And we have some people working on examples of that. A simple question is, it's a fixed plane focus. There's a lot of stuff in the Xbox where you can define your region of interest for auto gain control and for zooming into a particular location. We didn't have the time to do that on the PC, so the image formats that you get is currently what's being available. The question I get a lot is, what's the YUV video type? And how is that different than the RGB specifically? And the answer is that the YUV is the hardware sensor converting it to YUV on the chip before it's sent over the wire. But because the YUV data is much bigger in bandwidth, we can only send it at 15 frames a second. But it does look better than the RGB because the RGB is converted from bare, from the high resolution thing. It converts it down to 640 by 480 RGB. But because that's too high of a bandwidth, it has to recompress that before it sends it over the wire because it's 32-bit or 24-bit, and it ends up looking a little bit pixelated. So if you want a better video quality, use YUV but know that it's at 15 frames a second instead of 30. So when the data gets captured, we put timestamps on the images and we put frame numbers on the skeleton image data. A matching frame number on the skeleton data will match whatever the depth frame is so that you know how to correlate the two. But I'm currently unaware of how the frame number should work if you can't process at full frame rate. On the Xbox, it guarantees that the skeleton processing is going to work at full frame rate. So I'm not sure what the Xbox's intention was if frames were dropped, what the frame number should do. I think the frame number should skip and indicate to the user that frames were dropped. So for the commercial release, we're going to get this right. But currently, the frame number just increases. Another question gets asked a lot is skeletal shakiness, taking out high-frequency jitter. Some people aren't aware that we have a transform smooth method that will smooth your skeletal data out over time and do a double logarithmic smoothing on it, which seems to give pretty good results. Some people try to treat the motor as a servo and track people that are moving or up and down, and that doesn't work because we don't want the motor to burn out, so that's why we limit how many times per second you can set the motor position. I get asked a lot about facial recognition and gesture tracking, and those are obviously not in the SDK right now. And the question that seems to stump everybody is the tracking ID and which skeleton slot does it get into. When we track bodies, we can track up to 6 bodies at the same time. But we only do skeletal tracking on 1 or 2 people plus a potential third candidate that is never surfaced to the public. But the tracking IDs are when you walk into view and it recognizes that you're there, it assigns you a tracking ID. As long as the skeleton is being recognized, that tracking ID stays the same. If somebody occludes you or you walk off the screen and come back, that tracking number will change, and that's by design. It won't come back and recognize that you're the same person. It just recognizes that you're a body. That tracking number is always increased every single time a new recognition is done, and it's increased a little bit at random, so you can't count on a certain behavior for that tracking ID. There are 6 skeleton slots that you could be recognized in, and when you come back into view, if you're the second person that walks in, if you walked off the screen and come back in as the second person, you won't necessarily be in the same skeleton slot as if you were standing in front of the camera by yourself before. So right now, the only thing that you can count on is if the tracking ID is the same as it was the last frame, that you know that that skeleton is still you. That's currently the only information that we're giving you until we do identity recognition. So a lot of people ask about how to record and play back streams. We know that this is a very highly requested feature. Tell you the truth, privately, I have it working, but it's not up to release quality code, and I find it very valuable for testing. So I'm sure other people will too. And one of the things that we get asked a lot is the horizontal flippedness. It confuses some people. So it's sort of logical, but a little bit confusing. Video is flipped so that you can see yourself. So if you're standing in front of the monitor, video is flipped left to right so it looks like a mirror. If you ask for just depth data, it assumes that you want to do the skeletal processing yourself. So it gives you the format, the horizontal format, and the way that the camera itself sees it, and it figures you're going to do it your own way. If you ask for a depth plus player index, it assumes that you want to do something with the depth data that relates to the video, so it flips it the same way as video. So depth plus player index is flipped left to right just like video. But skeleton data comes through based on just the depth camera, so it's unflipped. But if you convert the skeleton data to color pixel coordinates, it flips it because it assumes that you want to draw it on the screen. So it's a little bit confusing, but kind of logical. If you're dealing with video stuff in any way whatsoever, it assumes that you're using it as a mirror. If you're using just depth or just skeletal, it assumes that you want to do your own. A lot of people want to go from skeleton coordinates to color pixel points. If you're using the high-res formula, or if you're using the high-res video, there's not currently a way to do that. But if you're using the 640 by 480, there's a new image to get color pixel coordinates from depth pixel. I noticed on the forum today that there's some people that say that it's not working exactly correctly. I don't know what the answer is to that yet, but I know that everybody wants to do that, so it will be addressed soon if it doesn't work. I think it actually works fairly well. We seem to have a lot of people up on the forums using OpenCV. So if you run into a thing, or your students run into a question about how to get the data into an OpenCV image format, there are a lot of people up on that forum site that know how to do that, and it appears to be fairly easy. Those are my deep dive questions, and I was going to reserve the rest of the sessions for answering questions for any type. Nobody? Yes? Oh, let's let the microphone come.
So one of the things I'm interested in doing is coordinating the sound source information and the vision information.
Mm-hmm.
Now, if you get basically the angle in one, what exactly is the mapping process to, let's say, the depth information?
Well, that's a good question. The angle that you're going to be getting is going to be at an angle from the center, from what I know about audio. So the skeleton coordinates that you're getting, if you're tracking skeletons, will be at an offset from the center of the camera as well. So as long as the camera is on a horizontal level playing surface, you should be able to sort of map the audio angle to the closest skeleton.
Well, so the visual angle subtended by the camera is the same as the nominal one in the audio? Or how does that work?
I don't think, if it's in radians, you would have to calculate the angle based on the skeletal coordinates. The skeletal coordinates gives you millimeters from the center axis of the camera, actual real life millimeters. So you should be able to calculate the angle of the skeleton based off of those millimeters from the camera.
And also, speaking of millimeters, is it really millimeters, or what's the noise or the error bar on that?
I don't know what sort of the fine grain resolution is. When I've looked at the depth image myself, it seems a bit grainy. It depends on the lighting, and I don't actually know what the angular resolution is of the camera. I know that the actual resolution is around 640 by 480. That if you try to get more accurate resolution than that, the information starts to become interpolated from testing that was done on the actual cameras down in the firmware, rather than what happens on the PC, which is the end result that you get from the chip.
Can I just comment on that one, Alex, just to augment? So I think the community at large has done some empirical studies to try and analyze some of those very questions. So if you check out what the community itself has done experimentally, just looking at the data coming off the camera, there is some information out on the web, but it's not information that we publish ourselves.
Any other questions?
Was this SDK designed in a way that you can extend the skeleton type in the next release?
So extend it in what kind of way?
That you can, in the next release of the SDK, you can provide different kind of skeletons.
You can provide which?
Different kinds of skeleton. I mean, only the skeleton of my arm or my hand.
So are you saying, are we going to provide different types of skeletal trackers, or are we going to provide you with the way of writing your own skeletal trackers?
Can be. I mean, is there...
I know there are many people at Microsoft that want to recognize different types of gestures and skeletal parts, but I don't know about specifically what they're planning. But there's certainly possible for you to take the depth data and write all sorts of recognition libraries off of it. Beyond that, I'm not aware of any sort of extensions to the skeletal tracking, besides making it better and better.
Can you tell me what kind of interference issues there are when you're using multiple Kinects?
Interference issues meaning USB bandwidth?
Oh, sorry, no. The fact that they're both trying to project infrared into the same into the same parts of the scene.
That's an interesting question, because I never thought of that, because the skeleton tracking stuff, because the skeletal stuff is non-reentrant because it got ported from the Xbox, we have a limitation that if you're using more than one Kinect can do skeletal and the other one can only do depth. And that seems to provide, those would both use IR, so it's interesting that they both seem to provide valid images. I haven't really noticed an interference pattern mismatch because of the two IR sensors. That's an interesting question.
That's really interesting, even when they're imaging the same surfaces.
Yeah, and I don't know. Yeah, I don't know. That's
okay,
a
thank
fascinating
you.
question. Yeah, the IR would bounce back exactly the same place that it came from, so that I don't think IR really reflects off of things very well. If it's a reflective surface, I think it wouldn't work. If it's an absorptive surface, I think that there shouldn't be a problem.
But it's a time of flight sensor, right?
No, it's not. It's trigonometry. Gavin misspoke earlier. It's not time of flight, the current camera. The camera in our system is not time of flight. It's structured light. The Wikipedia page is correct.
What's the structure?
What's the structure?
Yeah.
It's a dot pattern. If you get out your camera and have a look at the screen, you should be able to detect that. And there's some pictures on the web. There's some good YouTube videos of what the dot pattern looks like. I don't know whether the dot pattern is unique per camera. I would think it is, but I don't know.
Number 4?
Did anyone try moving the Kinect together with a walking person beyond the 4 meters?
Moving the Kinect and doing what with it?
Say following a skeleton along 100 meters of walk.
I'm not aware of anybody trying that.
So the only experiment you're aware of is a person standing in place.
Well, we have a Kinect in the hallway, and it's set to recognize anybody that's walking down the hallway, and it recognizes people that are walking towards or away from it or sideways all the time. It seems to work rather well.
Up to 4 meters?
That's about the limit. Yeah, up to about 4 meters. Yeah, anything farther than that gets clamped. I've never heard of anybody trying that test, having a moving Kinect while at the same time somebody's walking. Sorry.
One of the things that I'm interested in is having, when you have the skeletal tracking, you're also utilizing physical objects as well. And when you're holding a physical object, potentially you're going to occlude yourself. So I was wondering if you guys had any experience dealing with that. And
yeah, actually, I hold stuff in front of it all the time, like books and backpacks and wearing a hat and baggy clothing. I don't know how those algorithms work, but they do a phenomenal job of inferring where the skeleton is based on where it saw the last things.
Mm-hmm.
So I think the internal mechanism works so that it recognizes you up until a point, and if it doesn't know where you are, then it uses as much information as it can to infer where the rest of your arm is. I think it works ridiculously well for the times that I've been walking up holding a backpack or something like that that's occluding my hands, and I guess it just knows. It like does centroid recognition, like knows that this is part of my arm, so the rest of my arm must be up here.
Mm-hmm. The other quick question was, aside from the smoothing, are there any other parameters that you can set, or for the skeleton tracking, any other things you can do?
Not with this release. I don't know what's going to happen with the commercial release.
Okay. I guess the question I asked earlier was, when you rotate your body 360 degrees,
Mm-hmm.
the skeleton flips, so it can't track you when you're looking away from the camera. And, that's okay if you're dealing with like a television, but if I'm dealing with a head-mounted display, for example,
Yeah.
and I want to be able to rotate 360 degrees, then I have a little problem.
That's an interesting question. Make sure to post that on the forum so we can track it.
Okay.
This is more of a comment towards a question about the crosstalk between multiple Kinects. If you try to have the dot pattern on an object from different Kinects,
Yeah.
there is actually a small kind of crosstalk there, but it is much less than you would expect. So it's not that the whole depth tracking is breaking down because you have different Kinects projecting on the same object from different perspectives. There's some videos on YouTube. You can see that you get some reasonable tracking.
That's what I've noticed. It seems reasonable.
Yeah. And another thing about the question that you mentioned about the depth pixels converting from depth pixels to color pixels.
Yes.
I think this difference there could be coming from some individual differences in the Kinect devices. So sometimes the optics of the RGB camera and the depth camera are not completely aligned in the same way. So there are different individual differences. So that might be the reason why people might experience these small differences in color and depth space.
I can answer the question partially. I know that at the camera, they take these Kinects and they put them in a known configuration and they calibrate them. And the differences between what the depth camera sees and what the video camera sees is calibrated and then reburned back into the firmware. And we read those parameters at runtime, and when we do the mapping from the one space to the other one, we use those parameters. But because of even minute expansions and contractions in the plastic case and the lens and that kind of stuff can actually send that off quite a bit. I was surprised when I learned how much they can be off just from plastic flecks. And that accounts for a little bit of the error, but I think that what people were originally saying is that the values there, I think a lot of people were saying a flippedness problem, where they were sending in the values not flipped the right direction. And the other thing is, I read today that somebody posted that you need to shift the depth values left by 3 as if expecting player plus index date in the lower 3 bits in order to get the mapping to work correctly. And it's kind of funny. I'll admit I haven't seen that in my own testing. I tested it before I went out the door, and I saw the skeleton lining up exactly over top of myself. So I was pretty assured that the values were right. But there are some people that are saying that it's not the case. So we will investigate that before it becomes a commercial SDK and make sure that it's right. Any other questions?
It's getting near lunchtime now.
Yeah? Wake up.
Okay, thanks everybody. Thank you, Eric.
Yeah,
Thank you, Carlos. Let's go draw this to a close. I very much appreciate our two developers here working with us. Thank you very much for your time in talking to us today about Kinect. Please go and do your worst or your best on what you can on the SDK. If you haven't got any...
I want to say something.
Oh, go ahead.
On the forums. So if you ask questions, you will get me answering them. So don't be shy.
Yep, real people on the forums.
Yep.
If you're not fed up with NUI, we have the NUI panel coming up after lunch, chaired by my colleague and former manager, Kristin Toll. We've got some great speakers at the NUI panel, so please check that out if you haven't had enough of NUI. And then Rick Zalisky finishes off today with a plenary about vision-based NUI. So we got yet more NUI coming. Thank you very much.